Boom! We just got through talking a little bit about hash tables. So today we're going to discuss hash tables. So first and foremost, I'm going to create a thing here called hash table, or a project, or whatever you want to call it. I called mine hashtag, or hash table with no collisions. Because we're going to make a very basic hash table that does not take care of collisions. Basically, we're just going to ignore that for right now. So you can kind of get an idea of how it works. So, first and foremost, you make a new project, hash table, our main, and you right click new Java class. Should know that by now. The actual hash table, I could have done this all in the main. And in fact, in another project I did, but I decided to go ahead and just make a hash table object, as that's typically the better way to go. Now, what I've got here to start off with is a string array called table that has quite literally a million things in it. Well, a million slots. The bigger, the better, typically. Now, as I explained before, whenever we insert something, we have to have a hash function that decides where it is going to go in this giant array. If it's big enough and our hash function is good enough, things should not collide. But of course, we're going to use a very simple hash function that could very easily cause collisions, but this depends on what you're doing here. So now, first and foremost, we should look at the hash function I'm going to use. And as I said, I'm going to make it very simple. So basically what I've got here, if you take a look at this, is I have a value, a, set to 0, and I'm going to go through and basically just tally up the ASCII value of every character in the string that I want to insert. So if I want to insert Bob, it's going to tally up what those values are. And then it's going to figure out where that goes on the length of the table, which is a million. So if the ASCII value actually ends up being, for some odd reason, 10 million something, it will actually cut it down using this modulus. So if it was, let's say, my size was 10 and this hashed out to be 27, it would end up going to 7. Subtract 10, subtract 10, 7. That's what the modular arithmetic here does. So, and it's going to return where that hash is going to go, the location. That's what the hash function does. And like I said, this is very, very simple. Typically, you'd want something a lot more complex than this. Bunch of funky math. You can look it up online. These can get super complex. I'm just wanting to explain pretty much how it works, not show you a super complex one. So, first off, when we have our hash table, we need to insert things into it. So, we send it a string. And actually, I don't think I have to have that anymore. I did a lot of adjustments to make this a lot more legible. So probably I can just erase that and just make that in there. So let's fix that while I'm here. There we go. Extra thing you don't have to write. You're welcome. So where does this value go in the hash table? Well, I call the hash function. It's going to go in and do the math by adding up what those ASCII values are. Then it's going to plug it into this integer. Now, if the table at that location, let's say it ends up at location 42, it'll say, all right, table 42. If it's null, that means it's empty. I just go ahead and plug my string there, in this case. There we go. Yeah. Plug my string there. Now, if it's not, then, in this case, I have this written as nodes, but if my table is null, put it in there. I say it's inserted. Else, that means it's not empty. Something's there. There's a collision. So I just write out, there's a collision. Oh noes. And that's it. We're not going to insert it. We're not going to deal with collisions here. Now, if I wanted to deal with collisions, what I would need to do, and I think I discussed this last time if I'm not mistaken. Let's see here. Is I could use, instead of a single array, I could use an array of array lists and just add it to the array list. That would be pretty easy. You could also use a linked list, a node, and just have a next. That's possible too. So there's 2 or 3 different ways you could probably solve this if we wanted to take care of collisions. Now, insert's pretty easy. We get the number, we put it in there. So as you can see, instead of searching through the array, figuring out where it needs to go, reshuffling or doing whatever, we don't have to worry about that. We're not worrying about keeping things in order or anything like that. We want to find something, well, we see where it hashes out to and go directly to that place. It's like a little directory. If I want to know what building someone's in, what room they're in, I look down the list. There they are. I go directly to that room. As opposed to going door to door. Hey, is Bob here? Nope. Is Bob here? Nope. Is Bob here? It would be really, really tedious. It's much more efficient that way. Now, if I want to delete something, in order to delete it, I have to find it first. So I've got this find method here. And what it's going to do is see if what I'm looking for is in there. So I run the hash function again. And if the table in that location is null, then it's not found. It's not in there. Maybe it's been deleted. Maybe it's never been in there. I don't know. Else, if table is equal to what I'm looking for, I found it at that location. Now, I have another else here, and this is the case, let's say, so it's either not there or it is there, you would say. But there's one other possibility in that it's supposed to be there, but something else is there instead. This would mean that, there was a collision at some point, or what we're looking for hashes out to the same location. It should be there, but something else is. That's what this is. If there's a collision, it goes to this. So basically, this is going to return true or false if it found it. So we look back up at my delete. And what we've got here is, well, if not found, then you can't delete what doesn't exist. But you can try. Else, that means we did find it. And I just say, well, int a is the hash. I'll run the hash. And then I will null that out. It is deleted. Poof. Gone. Now, of course, if there was a collision, let's say, in this case, this would be, I couldn't find it. Else, it's in the list. I would just remove it from that location because I did find it. If there was a collision, this is where I'd probably put my extra code. For example, I have to check, is the first item in the list, for collision, let's just say. If the first item in the list isn't what I'm looking for, then, well, go down that sublist and find it. And delete it, I say. Delete it. Find/delete. Like so. So I would have that extra little thing in there. And the same would be true here. In my insert, if I got to this else, it's not empty, there's a collision, instead of just doing this, I would add it to the list in that array location. Or list, node, whatever you'd want to use. You would just add it to the end. If it's a linked list, you would just go next so you got to the end and pluck it there. If it was an array list, you would just add it, and it would just go to the end. So this is where I would do that. Now, we've got insert, delete, and we got find, of course. And find would be here. It should be there, but it isn't. Well, this would be checking that first location. I would have to check, If it's not at the first location, it must be further down. So, or it could be further down. I basically check the entire either array list or next until I get to null, and then I know it's not there. I have to adjust basically this code here for that. Now, display. All this is going to do is just print the things that are in my array, or in this case, in the hash table. So I have a little count at the top. Begin hash table display, just a little message, and then I go through my list. If the table, is null, then, or I'm sorry, not null, then I print, whatever that thing is at that location. I increase the count. At the end of this, once it prints each item and where it's located at, I print the number of items found. Now, if I had a, let's say, if I was dealing with collisions and I need to print, I would have to, check here. Well, if it's not null, then I'd have to go another little loop and basically go the length of that sub array or that sub count, whatever you want to do. What is the length of this particular little list? I'd have to do that. I think array lists probably would be easier, but we've done linked lists, so it wouldn't be that hard to add that and use that functionality, I guess. But there you go. This is basic hash table with no collision, but with a little bit of extra in there to tell you how we would kind of go about doing it if there was a collision. Now let's see it in action. Go to my main. Oh, I'll just roll through it one more time for everybody. We've got our string array, our insert, our delete, our find, display, and the all ever important hash function. And yes, I am aware that of the hilariousness of the fact that we're doing hash tables around 420. But anyway, the main is just a blank. I would make a hash table like I would a linked list or anything else. And boom, it's just a blank array basically with some functionality. I create a string and I insert the string into my hash table. We get a little message. It's inserted. Okay. I insert moo. Okay. Moo is inserted. So it says, okay. We'll leave the display on here. And it should show me moo is at this location and this one is at that location. Pretty simple. Seems to work. And every time I do this, they go to the same locations. It's not going to be random. I want to insert that first one again. And this should be a collision. Oh, there is a collision. So I want to insert Now remember how our hash function works. It takes the value, ASCII value of each letter and tallies it up. And that's how it figures out, where to put this. If we wanted this to be better, we might take the ASCII value of each one and multiply it, divide it, do some math or something, and then figure it out. But since the letters are exactly the same, what's going to end up happening is that's going to be a collision too. A second collision. Let's put a little print here to separate that. There we go. So there's two collisions. Moo and go to the same place. Now I try to find and it's going to tell me that it should be here, but something else is instead. That means it collides with something else. Now, if I try to insert capital M, the ASCII values for those are different. That will perfectly be fine going in there if it was in there. But it's not in there because it's capped. Now, if I wanted to insert it, t.insert, insert, moo, moo. It should be able to find it now. Moo moo found at location 630. And you see the different locations. Now, I want to find B, which is that first thing I hunted for. It's at that location. Good. I want to insert fuzzy pickles, because you have to. And that ends up being popped in at 1,299. Remember, we got a 10 million to play with, but... And then I can delete moo moo. Moo moo deleted at that location. And I can try to find it again. And it's not going to find it this time because it's removed. It's nulled. So this is your basic hash table, and you see how quick it is to insert, delete, find stuff in it. One of the more efficient data structures to use. Hopefully you got something out of that. This, as I said, is the main. Doesn't really require much, since everything is pretty much being done inside the hash table object here. If you have any questions or problems or any issues, just let me know.